Here we will talk about the analytical method of a parallelogram law of vector addition. So when two vectors A arrow and B arrow are represented both in magnitude and direction by the two adjacent sides of a parallelogram, then the diagonals of the parallelogram will represent in magnitude and direction about the resultant vectors. Okay, so here we shall talk about the magnitude of the resultant vector. So to find out the magnitude of the resultant vector, then we consider this figure here. So this vector A is represented in magnitude and direction by the sides OP, and vector B is represented in magnitude and direction by the sides OQ of a parallelogram. Now if you write this, you'll get a parallelogram OPSQ. Okay. Now like before, if this theta is the angle between, sorry, I made a mistake, this is not theta. Theta here, it is this angle. Okay. Theta is the angle between, suppose this is vector A acting in this direction, this is vector B acting in this direction, then theta is the angle between A and B. Okay. So if the angle between A and B is theta, then what is this angle? Because this OQ is parallel to PS. Okay. If this angle is theta, this angle also should be theta because they are corresponding angle. So therefore, I'll get this as theta. Now, if I drop a perpendicular from the point S to the extended line OP, then you'll get this point N, and this triangle here, P and S, will be a right angle triangle. So in this right angle triangle P and S, if you find sine theta, sine is equals to perpendicular by hypotenuse, which is NS by PS, or sine theta is equals to NS upon, now this PS is the sides of a parallelogram, and in a parallelogram the opposite sides are equal in length. So if OQ is equals to B, then PS also should be equals to B. But when I say PS, I mean only the magnitude of the vector B. So instead of PS, I'll write B. So just NS is equals to B sine theta. Okay. So similarly, if you take cos theta in a triangle PNS, then you'll get cos theta is equals to base by hypo, that is Pn by Ps, or cos theta is equals to Pn by Ps. Now this Ps, okay, I think I made a mistake, or is it fine? Pn by Ps, yes. Now, again, how much is Ps? Ps is B. Okay, so Pn is equals to B cos theta, right? Okay. Then, in a right angle triangle ONS, in this right angle triangle, OS is the hypotenuse. So therefore, OS square is equals to ON square plus NS square. Or, how much is OS? OS is a vector R. So in magnitude, it is R square equal ON. Instead of ON, I'll write OP plus PN. Whole thing square plus, instead of NS is equals to B sine theta. And when you square, you'll get B square sine square theta. Alright. Next, R square is equals to OP. OP is equals to the magnitude of a vector A plus PN. PN is equals to B cos theta. Whole thing square plus B square sine square theta. or r square is equals to, applying a formula, a plus b whole thing square, you'll get a square plus b square cos square theta plus 2ab cos theta plus b square sine square theta. Okay, or r square is equals to a square plus, now combining b square cos theta with b square sine theta, then you'll get b square, and inside bracket if you take common b square you'll get cos square theta plus, from here you're left only with sine square theta inside bracket, and the term that we have not taken is 2ab cos theta. Again, r square is equals to a square plus b square, and you know this is equals to 1, so 1 times b square is equals to b square plus 2ab cos theta, or just r is equals to root a square plus b square plus 2ab cos theta. So this is equation 1, and this equation 1 gives you the magnitude of the resultant vector r. Okay, next, to find the direction of vector r. Now if this beta is the angle made by the vector r with the vector a, then tan beta in this right angle triangle ONS, tan beta is equals to NS by ON, or tan beta is equals to NS. Now this NS is equals to B sine theta, and instead of ON I'll write OP plus PN, or tan beta is equals to B sine theta upon OP. OP is the magnitude of a vector A plus PN. PN is equals to B cos theta. Okay, so this is my equation number 2. Alright, so if you know this beta, again you will know the directions of the resultant vector r. Okay, so in a similar way you can do it by yourself to find the special cases. So in that previous video we have seen 3 special cases, that is when theta equals 0 degree, when theta is 90, and when theta is 180 degree. So again the same thing you will get in this case. Okay, so this is all about the analytical method of parallelogram law to find the magnitude and the directions of the resultant vector r.